I stood in that basement, hands black with old grease, and I was crying. Not because Dad had passed a week before, but because of this refrigerator. This 1954 General Electric. White as a bone, standing in the corner of that basement like it owned the place, still running. That compressor hum, low, steady, tireless, like it didn't know Dad was gone, like it had no plans to follow him. My name is Margaret Calloway. I've spent 20 years writing about American families. What they hold on to, what they lose, and what they never realize is gone until it's too late. Today, we're not talking about a refrigerator. We're talking about what America used to build and how we lost it. One screw at a time, one plastic panel at a time, one generation at a time. It was an October afternoon in Ohio. Sky hanging low, air cold enough to smell the cast iron cooling off, and every old thing in that house suddenly felt important in a way I couldn't explain. I bent down and put my hand on the steel shell of that refrigerator, felt the cold press into my palm. Thick steel, solid, cold the way steel is cold, not the way plastic is cold. I stopped breathing. This wasn't the cold of an appliance. This was the cold of something built to outlast everything around it. That old girl didn't answer me with words. She answered by still being there, 70 years later, while 3 refrigerators I bought after 2000 are rusting in a landfill somewhere. Yeah, you know exactly what I'm talking about. But to understand why she's still running, we have to go back. Back to a time when America was building something entirely different, with an entirely different philosophy. One we let die so quietly nobody even noticed it was gone. America gave the order. No more refrigerators. March 31st of that year was the last day any factory could use strategic steel for civilian production. After that, every sheet of steel, every weld bead, every bearing belonged to the war. No negotiation, no exceptions. The Frigidaire plant in Dayton, Ohio, the place that used to make refrigerators for American housewives. It switched its line over to aircraft propellers and aircraft machine guns. The workers weren't retrained, didn't need to be. They just kept applying the only philosophy they knew. Build it so it doesn't break. Damn. Think about that for a second. A machine gun bolted to the wing of a B-29, 30,000 feet up, 50 below zero. Vibration frequencies that'll shake loose a bolt right here on the ground. That gun was not allowed to fail. Not because of quality standards, not because of liability, because the man sitting in the tail gunner position behind it would die if it did. Simple as that. No board meetings about it, no risk assessment reports filed, just steel and will, and the hands of Ohio workers who refused to do sloppy work. Then the war ended. 1947. Frigidaire reopened its civilian line. Those workers, the ones who just spent 5 years building under the standard of get it wrong and somebody dies, they walked back into that factory and started making refrigerators again. Nobody ordered them to change. Nobody told them this was just a household appliance. Didn't need to be perfect. Their hands had already changed, permanently, and they weren't about to forget it. Now let me tell you about the heart of that refrigerator. And I'm not using that word to be poetic. Pull the compressor off that 1954 GE and set it on your workbench. Any machinist who lays eyes on it will nod and say, this was built to run, not built to sell. Cast steel housing, one solid piece. Thick enough that when you knock on it, you hear a dead thud, like knocking on an engine block. Sealed completely inside, not one molecule of air, not one particle of dust allowed in. The GE engineers called it hermetically sealed. I call it righteous arrogance. The outer shell is not paint, not plastic, not some polymer coating that starts peeling in 10 years. It's porcelain enamel fired directly onto steel. The same technology military hospitals used on surgical basins. Same standard. Because nobody was allowed to let that fail. That was where men's lives got put back together. You can swing a hammer at it. It won't chip, it won't rust. It'll look at you and go right back to work. And that door that closes with a deep, solid thump, I will hear for the rest of my life. It works on the same principle as the watertight doors on the USS Forrestal. Rubber gasket pressing continuously, evenly, around the entire perimeter of the door frame. Not one gap. Cold air doesn't get out. Moisture doesn't get in. On a warship, that principle keeps seawater from killing men. In my mother's kitchen, it kept the butter cold and the milk fresh. Same philosophy. Different address. America didn't design that refrigerator to be convenient. America designed it to never have to apologize. I stood in that basement a long time after I understood all of this. Dim yellow bulb overhead, smell of old concrete and grease, Dad's smell. Sunday mornings when he'd have his head under the hood of something in the garage while we ate pancakes upstairs. He never explained why he fixed things instead of replacing them. I think he figured that was so obvious, it didn't need saying, and that refrigerator just stood there. Still white, still square, door still sealing shut with that same deep thump, same as the day he brought her home. When I put my hand on that steel shell one last time before I hit the light. Felt 70 years of cold press into my palm. I understood. Dad didn't keep her because he was cheap, not because he was too lazy to shop for something new. He kept her because he belonged to the same generation that built her. A generation that believed if something was made with conscience, it deserved to be treated with conscience. And somewhere between his generation and mine, we let that belief die. Quietly. No ceremony. No eulogy. One plastic part at a time. Then I hit the light. The basement went dark, but that sound was still there. Low, steady, tireless. The hum of a 70-year-old steel compressor still doing its job. Like an old soldier still standing watch long after anyone stopped giving orders. A reminder of an America that once believed a refrigerator, like a warship, should be built to never surrender. Picture an August morning. 1945, Newport News Shipyard, Virginia. The war is over. News of Japan's surrender came through the radio before dawn. By noon, the whole yard knew. But nobody punched out early. Those workers kept their heads down over the steel, kept swinging hammers, kept checking every weld, because that was the only thing they knew how to do. And they didn't know how to do it any other way, but right. One of those men was Harold Voss, 42 years old. Master machinist, 17 years in the trade. His hands were so calloused that in winter he couldn't feel the cold through his gloves. He'd spent the last 3 years of the war on the technical inspection team for watertight door systems on Essex-class carriers. Ships nearly 300 meters long, 90 aircraft on deck, thousands of steel doors that had to seal completely before that ship left port. Harold Voss's job wasn't building ships. His job was to stand in front of every watertight door and ask himself one question. If this ship takes a torpedo at 3 in the morning, does this door hold? How many men die if it doesn't? And he didn't walk away until the answer was, it holds. 6 months later, Harold Voss walked into the General Electric plant in Louisville, Kentucky. Quality inspection, new refrigerator line, better pay than the shipyard, shorter hours, closer to home. Friday dinners with his wife and kids. The plant manager walked him down the production line on his first day and pointed to a compressor fresh off the assembly. Harold Voss stopped, didn't say a word, bent down and knocked on that steel housing with his knuckle. Listened to the ring. Then he straightened up and asked the manager a question the man never forgot. How many years can this run continuously without being opened up for inspection? The manager looked at him. Couldn't figure out why that was the first question out of his mouth. 10 years, maybe, he said. Harold Voss nodded slowly. Then he said, on my ships, the answer had to be forever. Because if it breaks down in the middle of the Pacific, there's no repairman coming. The manager figured that was just a new hire being humble. He had no idea that Harold Voss had just carried an entire design philosophy out of a warship yard and straight through the front door of a civilian appliance factory. And that philosophy was going to leave its mark on every GE refrigerator built for the next decade. Harold Voss wasn't alone. Across America in 1945 and 1946, tens of thousands of men just like him were doing the same thing. Walking out of war plants, setting their toolboxes down next to the gate of some civilian factory, and carrying inside something nobody asked them to bring and nobody could stop them from keeping. Not blueprints, not materials. What they carried in was a single question, asked before every decision, every weld, every part, every seal. Who dies if this fails? The military called that standard mil spec. But to Harold Voss and men like him, it didn't have a name. It was just how you worked. Let me give you one detail so you understand what that actually looked like on the floor. At the shipyard, every weld on a carrier's hull got checked twice. Once by eye, once by X-ray. Not because the process required it, but because the welder knew that when he went home that night and sat down to dinner with his family, 1,000 young soldiers were sleeping on the other side of that weld, somewhere in the Pacific. When Harold Voss walked into GE and saw an inspector glance at a seam and sign off on the form without stopping, he walked over, put his hand on that man's shoulder, and asked, "Did you knock on it?" The inspector looked at him like he'd lost his mind. Harold Voss put his knuckle to that weld, listened, then quietly wrote something in his notebook. That wasn't perfectionism. That was the muscle memory of a man who'd lived through a war and couldn't shut it off just because peace had come. It's no accident that American refrigerators from the 1950s are still running while the engineers who designed them have been in the ground for decades. That's the inevitable result of a philosophy forged in wartime. If you can't fix it in the middle of the ocean, don't give it a chance to fail in the first place. My father never talked about his work, not because he was secretive, not because he was modest, but because to him, work wasn't something you talked about. It was something you did. And when it was done, it was done. 23 years as a machinist at a Cleveland plant. Every Monday morning, he put on his blue work shirt, drove out at 6, came home at 4:30 with hands black with grease he never fully washed clean. That oil had soaked into the lines of his palms like a tattoo nobody chose. He didn't complain. He didn't wear his pride on his sleeve. He just worked. It took me years to understand that silence wasn't an absence. It was the language of a generation that believed dignity lived in the product, not in what you said about it. To understand why those 1950s refrigerators last the way they do, you first have to understand who built them. Not technically, humanly. The generation of American workers born between 1900 and 1920. The ones hitting their prime in the 1950s. They'd already lived through the Depression before the war ever started. They knew hunger. Not as a metaphor. Real hunger. Hungry enough that a torn shirt got patched instead of tossed. Hungry enough that a bent nail got pulled from an old board and straightened out for another go. Hungry enough that the concept of throwing away something that still worked didn't exist in their vocabulary. Not as a moral position, as hard-won experience. Then the war came. And those men, the ones who'd learned to respect materials during the Depression, walked into defense plants and learned one more lesson. That sloppy work could kill people. Not in the abstract, literally. Specifically, with names and addresses. Dad didn't have an engineering degree. He had 15 years of experience and a feel for metal that no school could teach. When he picked up a steel component, he knew immediately. From the weight, from the sound when he knocked on it, from the way light caught the surface, whether it made the cut or not. No gauge needed, no data sheet. His hands were the most accurate inspection instrument in that shop. That's not mythology. That's the reality of an era when craft skill accumulated over decades. Not through a few training sessions. Skilled tradesmen in the 1950s spent years apprenticing, usually starting at 15 or 16, doing the smallest jobs in the shop, watching the men ahead of them, failing and correcting under the eye of men who'd already failed and corrected. An unwritten system. No certificates, but effective enough that what it produced is still running 70 years later. Yeah, I know what you're thinking. Margaret, you're romanticizing the past. Every era had lazy workers, cheap materials, bad product. True. Completely true. The 1950s weren't some flawless quality paradise. There was bad product. There were careless workers. I'm not arguing that. But here's what I am saying, and this is the part that matters. The 1950s had something we don't have anymore. Professional shame. When a worker turned out something substandard, he knew it. The man next to him knew it. The foreman knew it, and that knowing carried social weight. It hit his reputation on the floor, changed how his coworkers looked at him, changed how he looked at himself in the mirror every morning. No KPI dashboard captured that. No software measured it. But it was real. And it was what kept standards standing when nobody was watching. Dad said something to me once. I was little. I'd asked him why he was spending a whole evening fixing the lawnmower instead of just buying a new one. He looked at me and said, "Because I know who made this, and I don't want to be the one who threw away what somebody put their sweat into." I didn't understand it then. Now I understand he was talking about an unwritten contract. between the man who made a thing and the man who used it. Responsibility running both directions. The worker's obligation. Build something worth keeping. The owner's obligation. Don't throw away something worth fixing. That ecosystem. That circle of mutual respect. That's what produced refrigerators 70 years old and still running in basements across Ohio and Michigan and Indiana. So when the suits upstairs started asking questions about material costs, Harold Voss and men like him didn't see a threat coming. They couldn't picture the outcome. They'd been through the Depression, where discarding something usable was a sin. They'd been through the war, where cutting corners meant somebody died. Those two experiences had built a wall in their minds that had no room on the other side for any concept called deliberately building worse to sell more. That wall was their honor, and it was also their blind spot, their greatest strength, and their fatal flaw. Both at once, standing in Dad's garage after he was gone, hand on that blue work shirt still hanging on its hook, fabric stiff where the dried grease had built up into its own kind of armor. I could see a future coming where nobody would know what it meant to wear a shirt like that anymore. Not because nobody wanted to, but because nobody would remember that it was ever something worth being proud of. I want you to do something tonight. Go to your kitchen, stand in front of your refrigerator, whatever year it's from, and close that door. Slow. Don't push hard, just ease it shut until it pulls itself in and seals. Listen to that sound. Feel the drag of that rubber gasket pressing into the frame, and ask yourself, why does this door have to seal that tight? The obvious answer? Keep the cold in. Block the heat out. True, but that's not the whole answer. And the whole answer? The one GE engineers in the 1950s understood better than anyone doesn't start in a kitchen. It starts underwater, inside a warship taking fire. On every U.S. Navy vessel in World War II, the watertight door system was the last line between living and dying. When a torpedo tears open a hull, seawater doesn't flood the entire ship at once. It floods the breached compartment. If the watertight doors surrounding that compartment close in time and seal completely, the ship stays up. If they don't, the ship goes down, and every man inside goes down with it. That's why Navy watertight door design allowed 0 gaps. The system they used was called a dog clamp, a series of steel rotating lugs evenly distributed around the entire perimeter of the door. Each one, when driven home, pulls the door frame hard against the rubber gasket with equal pressure from every direction. Not just at 4 corners, not just at the center, the entire perimeter. No gap, no theory of perfection, just perfection. The rubber gasket on a watertight door wasn't standard rubber. It was vulcanized at specific temperature and pressure to hit an exact elasticity, soft enough to fill every microgap under compression, hard enough to hold pressure back without taking a permanent set. After every open and close cycle, it had to return to original form completely, non-negotiable. The dog clamps were designed so a sailor could drive every single one home in 15 seconds, in complete darkness. Because when a ship takes a hit, the lights going out is the first thing that happens. Shape, position, torque, all of it calculated so the hands work by reflex, no eyes required. Now, step off that ship. Step into a 1954 kitchen. The door on that year's GE refrigerator had a rubber gasket running continuously around the entire perimeter. Not 4 separate pieces joined at the corners, one unbroken loop. When that door closed, the gasket compressed evenly against the steel frame on the same principle the dog clamp used against a warship's door seal. Continuous pressure, full perimeter, no gap. GE's 1944 technical documentation described that requirement in language any Navy engineer would recognize immediately. The cabinet must be completely sealed. The door must fit tightly against the cabinet. The interior insulation must remain dry under all operating conditions. On a carrier, remain dry means men live. In a refrigerator, it means the compressor doesn't work double time compensating for moisture infiltration, and your family's food doesn't spoil. Different purpose, same principle. Down to the last detail. I know somebody out there is thinking, Margaret, you're stretching this. Refrigerators and warships just happen to use similar gaskets. There's nothing remarkable here. All right, let me show you the part that isn't coincidence. 1954, The USS Forrestal, the first supercarrier in the U.S. Navy, was being finished at Newport News Shipyard in Virginia. Same year, GE launched the refrigerator line we're talking about. Not random coincidence. The coincidence of a generation. Men who'd spent the best years of their working lives inspecting watertight systems on warships were carrying those same hands, those same eyes, that same single question into civilian plants across America. Not because anyone told them to apply Navy standards to refrigerators, because they didn't know how to design any other way. I call this standard contamination. When a generation of engineers trained by war steps into civilian industry, they don't leave military standards at the gate. They carry them in. And because nobody had yet told them to lower those standards, at least not yet, not in the 1950s. Your refrigerator got the benefit of the same thinking that designed watertight doors for aircraft carriers. That 1954 refrigerator wasn't built to last like a warship because somebody decided it should be. It lasted because the men who built it didn't know another way. And in that particular moment in history, that not knowing was the greatest gift they ever gave the American family. Down in that basement that night, I pulled the refrigerator door open and let it swing shut on its own, slow. And I looked at the bottom corner of the doorframe where the gasket bends through the curve. No seam. That gasket was one continuous loop. No splice, no joint. One piece of rubber running from start to finish, where start and finish are the same point. That wasn't a material-saving decision. That was a philosophy cast into physical form. One joint is one potential failure point. No joint means no failure point. On a warship, that logic keeps men alive. On my father's refrigerator, it kept the cold in for 70 years without a single apology. Not because that refrigerator was built from warship steel, but because it was built by men whose minds were warship steel. Then the basement went completely quiet. Just the low, steady hum of a 70-year-old compressor, and the sound of a rubber gasket holding a steel door shut. Exactly as it had done every single day since 1954, like an old sailor still standing watch at the compartment hatch. Long after the ship came home, long after the war ended, because he never learned any other way to exist than to finish his watch. I want you to meet someone. He has no name in the history books, no statue, no podcast. But he and thousands of men like him reshaped America more profoundly than any president of the 1950s or 60s. His name doesn't matter. His title does. Director of Product Cost Planning. He couldn't weld, couldn't read a blueprint, never once in his life put his hand on a seam to feel for vibration. But he knew one thing Harold Voss didn't. He knew that every extra gram of steel in a refrigerator shell was money left on the table. And money left on the table was a sin against the shareholders. And he had numbers. He had spreadsheets. He had closed-door meetings that Harold Voss was never invited to attend. To understand what happened next, you need one concept: 1954. The same year that perfect GE refrigerator came off the line, an industrial designer named Brooks Stevens put a name to something the business world would use for decades: planned obsolescence. The idea was simple enough to be terrifying. Design your product so the customer always wants something newer, even when what they already own works perfectly fine. Stevens thought it was smart business strategy. 6 years later, in 1960, a journalist named Vance Packard published a book that everyone in the industry read and nobody admitted to reading. He called it The Waste Makers. And he laid out two varieties of planned obsolescence being deployed against the American consumer. Type 1. Quality obsolescence. Deliberately engineer the product to fail sooner than the previous version. Not because the technology can't do better, because doing better means the customer doesn't need to buy again. Premeditated, planned, profitable. Type 2. Aesthetic obsolescence. Change the styling, the colors, the exterior design frequently enough that what you already own looks outdated, even though it runs perfectly. This one leaves no fingerprints, because the victim walks into the trap voluntarily. Packard warned that if this continued, it would lead to cheaper materials, production shortcuts, shorter product lifespans, and heavier repair bills for every American family. He wrote that in 1960. 50 years later, everything he warned about had happened, and worse than he imagined. That wasn't prophecy. That was a witness watching a killing happen right in front of him. Nobody had died yet, but the blade was already moving. In the 1950s, a GE refrigerator used sheet steel, roughly 2 to 3 millimeters thick for the outer shell. That material cost was a significant line item. The director of product cost planning looked at that number and asked, "Why do we need it that thick? Does the customer measure shell thickness before they buy?" The answer was no. So why not bring it down to 1 millimeter? Save material, cut weight, easier to ship, margins go up. Nobody in that conference room said, because thicker steel means the door closes with a thud that makes the customer trust the product the moment they touch it for the first time. Because it creates the feeling that this thing will never fail. And that feeling is why they recommend it to their neighbor. Nobody said that, because there was no line in the spreadsheet for the feeling of trust. This is how quality was murdered in 1950s and 60s America. Not by one big decision, not by a public announcement, not by a boardroom coup in the dead of night, but by hundreds of small decisions, each one reasonable on paper, each one impossible to argue against in the language of the conference room. Because the language of the conference room had no words for professional honor, no words for a craftsman's conscience, no words for the thud of a steel door telling you it would be there forever. And here's what keeps me up at night when I think about this story. The men who made those decisions weren't villains. They didn't wake up every morning with a plan to sabotage American quality. They were doing their jobs, optimizing costs, growing margins, meeting shareholder expectations. The system rewarded them for those decisions. The system had no mechanism to reward Harold Voss for knocking on every single weld. This isn't a story about good people and bad people. It's a story about two languages that couldn't understand each other. The language of men who built things with their hands, and the language of men who built profits with a pencil. And when those two languages collided inside the same company, which one won had nothing to do with right or wrong. It depended on who sat closer to the CEO. In the 1950s, Harold Voss still had enough of a voice to hold the line. In the 1960s, he was getting older. In the 1970s, he retired. And the man who replaced him didn't know why anyone had ever knocked on a weld with their bare knuckle. Because there was nobody left to teach him. That gap, the distance between the ones who knew and the ones who didn't, that's where American quality got buried. Not in a loud assassination, in the quiet forgetting of the generation that came next. So let me ask you the question I've been sitting with since that night in the basement. Did we lose something beyond a refrigerator that lasts? When we let the language of the pencil replace the language of the hands? Or did we lose something deeper? The belief that building something truly well was enough. That silent excellence, the kind that never needed anyone to know its name, was still worth calling great. Harold Voss never gave a TED Talk, never wrote a memoir, never got a corner office. He knocked on welds. He listened to the sound they made. He wrote in a notebook nobody else ever read. And somewhere in a basement in Ohio, the work of his hands is still running, still holding, still cold. Sunday mornings at our house had a smell. Not the toast from Mom's kitchen, though that was part of it. Not the coffee Dad poured from the glass percolator every morning before putting on his work shirt. The smell of Sunday mornings at our house was motor oil. That faint drift coming through the gap under the garage door, mixing with Ohio autumn air, making something I don't have a word for except safe. Dad spent every Sunday morning in that garage. Not because he had to. Not because something was broken and urgent, but because that was how he was alone without being lonely. Head down over a machine, hands working, mind thinking or not thinking, whichever he wanted. That garage was the only space in a house with 5 people that was completely his. I used to slip in there as a kid. No knock, no asking. Just push the door open and stand quiet at the threshold and watch him work. He never sent me out, never turned around to look, just kept working. And sometimes, when he needed a smaller wrench or a clean rag, he'd point in my direction without a word. And I always knew what to get. That was our language in that garage. No words, no explanation. Just the trust that the other person knew what was needed. One morning, I was about 9. Dad was fixing the old washing machine Mom had wanted to replace the year before. The water pump had failed. He pulled it out, set it on a piece of cardboard on the garage floor, and sat looking at it for a while without saying anything. Then he stood up, wiped his hands on a rag, and drove to the parts store at the end of the block. The one where the owner knew Dad's name and knew the model number of every appliance in our house. 2 hours later, Dad came home with a replacement part, sat back down, and had it fixed before lunch. Mom asked why he didn't just buy a new one. He looked at her, then at the washing machine. Then he said something I've carried with me ever since. This is better than anything they're selling out there right now. Why would I throw away something better to buy something worse just because it's new? I was 9 years old. I didn't understand the full weight of it. Now, after everything I've researched and written on this subject, I understand that Dad had just summed up the entire American quality crisis in one sentence, not in the language of economics, not in industrial terminology, in the language of a man standing in a garage with greasy hands and a replacement part he'd just paid $3 for. Dad's generation, men born in the 20s and 30s, raised in the Depression, forged by the war, they had a relationship with objects that my generation doesn't have, and our children have even less of. Not a collector's relationship, not nostalgia, a relationship of practical respect. They respected objects because they understood that someone had made that thing with their hands and their conscience. And discarding it while it still worked was a denial of both the labor and the conscience of the person who built it. Dad never put it into words that way. But every time he sat down on that garage floor with a broken machine and a set of tools, he was saying it through action. He was saying, "This is worth fixing. The person who built it did their job right. I won't betray their work by throwing it in the trash." I call that craftsman loyalty. It has no official name, no hashtag, no movement behind it. Just a man in a garage on a Sunday morning, hands black with grease, carrying out a silent covenant with a stranger he'd never met. Someone who'd sat at a line in a plant in Louisville or Dayton and done their job right. Dad passed in 1994. I came home and cleaned out his garage, and I found everything. The red steel toolbox he'd used since the 60s. Every drawer organized so precisely, I didn't dare disturb it. The small notebook where he'd recorded every repair he'd ever made to anything in that house. Dates, problems, replacement parts, where he bought them. Handwriting small and steady, the handwriting of a man who was never in a hurry. And on the top shelf, wrapped in an old newspaper page, a spare water pump assembly for the washing machine, bought in 1975. In case the one running ever failed again. He had planned for a repair 20 years out. 20 years. Not out of anxiety. Not out of compulsion. That was how he loved. He prepared in advance for the things that mattered. He didn't let them fail suddenly with nothing ready. I stood in that garage for a long time, holding that water pump wrapped in old newsprint, and I understood that this was the answer to every question I'd been asking across everything I've written on this subject. I swallowed hard looking around that garage one last time before I locked the door, because I finally understood. Dad didn't fix things because he was frugal. Not because he couldn't afford new. Not because he was behind the times. He fixed things because he was the last person in our family who still remembered that every durable machine is a promise. The promise of the worker who built it, that this thing is worthy of your trust. And he refused to be the first one to break it. 1957. Frigidaire rolls out a new line with a name that sounds like money, the sheer look. Flat panels, no raised trim, pastel colors that made a housewife's kitchen feel like the future. Pink, mint green, butter yellow. That refrigerator didn't look like industrial equipment anymore. It looked like furniture. And America was hungry for exactly that. A kitchen that looked like tomorrow, not like a factory floor. Nobody noticed the thinner steel inside. Nobody asked about the gasket compound, cheaper synthetic replacing vulcanized rubber. Nobody caught that the fired porcelain enamel was quietly giving way to epoxy coating, lighter, faster on the production line, and it would start peeling in 12 years instead of never. All anybody saw was that mint green, beautiful as a dream. Plastic didn't invade America in a frontal assault. It seeped in. Slow, one small component at a time. Across 2 decades, from the late 1950s into the early 1970s. First, the interior liner. Instead of stainless steel or fired porcelain, manufacturers switched to ABS plastic. Lighter, easier to mold into complex shapes, significantly cheaper. Then the egg trays, ice cube bins, door handles, then plastic fasteners replacing metal hardware, then the entire hinge assembly. Every substitution had a legitimate technical justification on paper. ABS plastic doesn't rust. Plastic is lighter than steel. Plastic can be molded in color, no paint required. Nobody lied about those advantages. They were real. What nobody said out loud was that plastic gets brittle in sustained cold, fatigues over years of thermal cycling, and can't be repaired when it cracks. Only replaced. And only replaced was exactly what the director of product cost planning had been waiting for since the 1950s. Let me give you two sounds. Fired porcelain enamel on steel. Knock on it. You get a deep, solid ring. Doesn't chip, doesn't rust, repairable with specialty enamel compound. Still intact after 70 years. ABS plastic liner. Knock on it. Hollow thud. Yellowing by year 10. Brittle by year 15. When it cracks, you're either ordering a replacement part or buying a new refrigerator. Two sounds, two philosophies, two completely different ideas about what a refrigerator owes the family that bought it. Now picture this. 1972. A woman walks into an appliance store in suburban Ohio. She's looking for a new refrigerator. The old GE down in the basement still runs fine, but it looks so dated. The salesman walks her down the line. Brand new models gleaming under fluorescent lights. Avocado green, the color of the moment. Smooth white plastic interior. Better organized storage. Automatic ice maker. The salesman didn't lie to her. That new refrigerator genuinely was more convenient. Genuinely looked better by 1972 standards, and genuinely cost less in nominal dollars. The one thing he didn't tell her, because he didn't know or didn't think it was relevant, was that the old GE in her basement would still be running long after that avocado green model had gone to the landfill. She bought the avocado green. The old GE got pushed to the curb. And there on a suburban Ohio sidewalk on some unremarkable morning in 1972, an era ended without a funeral. A decade later, the EPA would mark that moment in the dry language of environmental reporting. Two surface systems listed side by side in a federal document. Porcelain enamel on steel. Painted steel and plastic lined. Two labels. Two worlds. The bureaucrat who wrote them treated them as equivalent alternatives. He didn't know he'd just written the obituary for one of them. The tragedy isn't that plastic is worse than steel. The tragedy is that we lost the language to talk about the difference. And we lost the last person in the store who knew enough to explain why the thud of a steel door was worth more than 10 years of convenience from a plastic egg tray. My father's generation felt that difference through their hands. Heavy and cold. Plastic. Light, light, and faintly warm. That physical knowledge told them everything they needed to know without a material science textbook. But the generation that came after grew up with plastic as the standard, not the exception. To them, a plastic refrigerator wasn't a step down. It was just a refrigerator. And when you don't know what you've lost, you can't grieve it. America's steel empire didn't collapse in a day. It melted out slowly, 1 millimeter of sheet metal at a time, one porcelain enamel panel at a time, one Ohio autumn at a time, into bright plastic molds and forgetting. I stood in my own kitchen not long ago, hand tight on the door of my 12-year-old refrigerator, looking at the yellowing ABS liner, watching the small cracks starting to form in the corner of the vegetable drawer. And I could see the future clearly. A future where nobody remembers that a refrigerator interior once came in stainless steel. Fired porcelain. Vulcanized rubber gasket formed into one continuous loop with no seam and no joint. Not because anyone deliberately forgot, but because the parts store at the end of the block closed years ago. And the man behind the counter who knew your father's name and the model number of every appliance in your house retired a long time ago. And nobody came to take his place. That GE refrigerator in Dad's basement ran for 70 years. Not 70 years without a single service call. Dad replaced the door gasket once in the 70s, added lubricant to the compressor twice. Total maintenance cost across 7 decades, under $40 at the value of the dollar then. Now let me put that next to the refrigerator I bought in 2008. Compressor failed in 2015. Control board failed in 2019. Sitting in a landfill by 2021 after 13 years and 3 expensive repairs. Total maintenance and repair costs across 13 years, over $700, not counting what I paid for it new. This isn't my personal anecdote. This is a pattern repeating across millions of American households, and it has specific technical answers. Today we're going through them one by one. Not out of nostalgia, because when you understand exactly why the old ones last, you'll know precisely what was taken out of the new ones. Start with the simplest thing, the outer shell. A 1950s GE refrigerator used sheet steel between 1.5 and 2.5 millimeters thick for the exterior, finished with porcelain enamel fired above 800 degrees Celsius. That enamel forms a chemical bond with the steel surface. It isn't applied on top. It doesn't adhere to the surface. It becomes part of the steel. The result? A surface harder than glass, impervious to water, chemically inert against anything in a normal household, and permanent unless something hits it hard enough to physically fracture it. The average refrigerator built after 2000 uses sheet steel under 0.8 millimeters thick, finished with epoxy coating or PVC laminate. That finish doesn't bond chemically with the steel. It grips the surface, and like everything that only grips instead of becoming part of something, it will let go. The question isn't whether it peels, it's when. But the most technically significant detail isn't the steel or the enamel. It's the compressor, the heart of the machine. And this is where the design philosophy changed most clearly, most deliberately, most unmistakably. A 1950s compressor sat inside a cast steel housing you could open with a standard wrench. Inside, pistons, valves, a crankshaft, bearings, separate components, accessible, inspectable, replaceable individually. A skilled mechanic could fully rebuild a 1950s GE compressor on a workbench in half a day. It was designed to be repaired, not designed to last forever, designed to be fixed when it failed. That is a completely different philosophy. The modern compressor is laser welded completely shut in a vacuum environment at the factory. No bolts, no access panel, no entry point for a user or a standard repair technician. When it fails, and it will fail because everything fails, the only option is replacing the entire sealed unit. Cost? Typically 60 to 80% of a new refrigerator's price. At that point, every rational consumer buys new. That's not an accidental outcome. That's an engineered outcome. The durability of that 1954 refrigerator isn't a miracle of materials. It's the consequence of a design philosophy that believed the person using the machine had the right to get inside it, and that the worker who built it had an obligation to make something the next person could fix after the builder was gone. Yeah, I hear the pushback already. Margaret, modern refrigerators are more energy efficient, cool more evenly, run quieter, have more features. Completely true. I'm not disputing it. Refrigeration technology made real advances. Modern compressor efficiency is genuinely better than the 1950s. But here's the right question to ask. Did sacrificing repairability have to be the price of better energy efficiency? The technical answer is no. A compressor can be both efficient and serviceable. What prevents that isn't a physical constraint, it's a business decision. A sealed compressor costs less to mass produce, and it guarantees that when it fails, the customer buys a new unit instead of rebuilding the old one. Energy efficiency is the reason stated. Long-term revenue is the reason behind it. And here's what keeps me awake now. Not anger, recognition. We are living in a world where the right to repair something you own has become something you have to fight to get back. Not a default, not common sense. Something American states are passing legislation to protect. They call it right to repair, because manufacturers have designed their products to be unrepairable without the manufacturer's permission. That 1954 refrigerator is still running. Not because it was lucky, because the people who built it believed that you, the person who bought it, had the right to open it up. Understand it, fix it. That right is what the 2024 refrigerator took away from you and called it progress. The basement went quiet. Just the low, steady hum of a 70-year-old compressor, still running, still doing the one thing it was built to do. No control board second-guessing it, no app monitoring it, no firmware deciding when its useful life is over. Just steel, and refrigerant, and a piston moving inside a cast housing that any mechanic in America could open up, if they wanted to, if they needed to, if they still remembered how. There's a man named Gary. Tennessee, 63 years old, retired electrician, silver hair and hands calloused like my father's. Last year, he pulled a 1956 Frigidaire out of a neighbor's trash. Neighbor had tossed it because it was too old. Gary spent 7 weeks on it, $40 in parts ordered from a restoration shop in Ohio, and a factory service manual he tracked down on an online forum built by people exactly like him. Then he posted a short video, not to show off. His son had asked why he'd spent 7 weeks on an old refrigerator. 2 million people watched that video in 3 days. Not because Gary did anything extraordinary, but because 2 million people were hungry for something they didn't have a word for. And Gary had just shown them it still existed. The American vintage appliance restoration community isn't a new movement. It's been living quietly in garages and basements for decades. Men and women methodically pulling things apart, cleaning them down, sourcing components, bringing old machines back. But the internet did something nothing had done before. It found these people in their separate garages and connected them. On specialized forums, you can locate the part number for a 1954 GE door gasket. Still manufactured, still indexed to the original model number. You can order a replacement capacitor for a 1958 Frigidaire compressor. You can download a PDF of the original 1955 factory service manual, the same document men like Harold Voss worked from every day, now scanned and shared freely by people who believe that knowledge shouldn't die with the generation that created it. She's not a mechanic. She's an elementary school teacher in Michigan, 58 years old. She bought a 1952 Kelvinator at a farm auction, spent 3 months learning online, corresponding with 2 veteran restorers over email, ordering a gasket from a small shop in Indiana. When that refrigerator started for the first time after restoration, that familiar clunk and then the low, steady hum, she sat down on her kitchen floor and cried. Not because of the refrigerator, because for the first time in years, she felt like she'd made something that would genuinely last. Here's what I want you to understand about this restoration movement. It's not about nostalgia. It's not about living in the past. It's about refusing to accept that something good needs to be replaced just because it's old. That's a philosophical position, not an aesthetic preference. And in the fast consumption world of the 21st century, that position takes more courage than most people recognize. I've spoken with dozens of restorers in researching this series, and they all say one thing. Different words, different ways of putting it, same meaning. When you pull apart a 1950s machine and look inside, you can see immediately that the person who built it wanted you to understand it. Everything has a reason. Everything is accessible. Nothing is hidden from the user or protected against them, because the user wasn't treated as an adversary of the machine. They were treated as the person who would keep caring for it next. Now look inside a modern appliance. Refrigerator, washer, oven, welded plastic housings, glued circuit boards, proprietary Torx fasteners not found in any standard toolkit. Red warning labels, do not self-repair, warranty void. That machine isn't telling you that you're not smart enough to understand it. It's telling you that you don't have the right to try. Restorers aren't behind the times. They're the only people in modern society exercising a genuinely meaningful form of ownership. The right to understand what you own, the right to fix it when it breaks, the right to refuse to discard it just because someone else decided its useful life is over. And they're passing that knowledge forward, not only through online video, through Sunday mornings in the garage when a grandfather teaches a grandchild how to hold a wrench, through small restoration club meetings in Midwest towns where 3 generations sit around an old machine and work out together why it isn't running, through long, patient emails that veteran restorers write to beginners. Detailed, no charge, because they understand that knowledge not transmitted is knowledge that dies. Dad fixed things because he respected the person who built them. Gary in Tennessee restores refrigerators because he respects my father, even though those 2 men never met. That's how a real legacy travels, not through bloodlines, through hands and conscience. I felt something tighten in my chest the first time I heard the rebuilt compressor in Gary's 1956 Frigidaire fire up on that video. That solid clunk, then the low, steady hum. Tireless, unhurried. I wasn't listening to machinery. I was listening to Harold Voss knocking on a weld in the GE plant in 1946, to my father sitting on the garage floor on a Sunday morning, to the worker in Dayton who put his hands on this thing for the first time and decided to do it right. Not because anyone required it, not because anyone was checking, not because anyone would ever remember his name. I started this series in a basement in Ohio, hand on the cold steel shell of a 70-year-old refrigerator. I'm ending it here. Same basement, same refrigerator, same steady hum that hasn't stopped once. But I'm not the same person who stood here with a question. I'm the person who stood here long enough to find the answer, and the answer is heavier than the question ever was. Across 10 episodes, we traced the complete life of a philosophy, born in wartime, forged by workers who had no concept of acceptable failure. It peaked in the kitchens of the 1950s, got betrayed by suits in conference rooms, got erased from memory by avocado green plastic and pastel pink enamel. And right now, it's being quietly resurrected by people like Gary in Tennessee and a school teacher in Michigan, working alone in garages and basements all across America. The story isn't over, but the next chapter isn't mine to write. Before I say what I need to say, let me put one final set of numbers in front of you. Not to complicate things, but because these are the kind of numbers that once you've seen them, you can't look away from. 1950s. Lifespan, undetermined. Still running. 1970s. 15 to 20 years. 1990s, 12 to 15 years. 2000s to present. 7 to 10 years. Every generation of refrigerator, newer, more convenient, better looking. And shorter lived. This is not a random pattern of technological progress. This is the result of 7 decades of deliberate decisions made by people who knew exactly what they were doing and why. So my question for you, and I'm asking it straight, no metaphor, no history to hide behind, is this. Do we accept that? Not a question about refrigerators. Not a question about plastic versus steel or planned obsolescence. The real question, do we accept living in a world where everything around us is designed to fail, to be replaced, to be forgotten, while we pay more, work more, and generate more waste than any generation before us? And if the answer is no, then what do we do differently? Starting tomorrow. I believe that every time you repair something instead of discarding it, whether it's an old refrigerator, your mother's washing machine, or the watch your father left behind, you are making a political act. You are telling the system you reject its philosophy. And the smallest political act carried out by enough people is still a political act. I believe that the knowledge of repair is a form of power that corporations do not want you to have. Not because it's dangerous, because it frees you from the endless buy new cycle. Learn to hold a wrench. Learn to read a basic wiring diagram. Teach your kids. That is not a skill from the last century. That is an economic survival skill for this one. And I believe that legacy is not something you receive. It's something you decide to pass forward. Harold Voss didn't know that his decision to knock on every single weld would feed American families 70 years later. My father didn't know that his Sunday mornings in the garage would become the foundation for everything I understand about the real value of objects. We never know which of our actions will echo forward. But we know that if we don't act, nothing echoes. That much is certain. Did we lose something beyond a durable refrigerator when we chose the convenience of plastic over the weight of steel? Or did we lose something deeper? The philosophy that what is made with conscience has the right to last, and what is given to you with conscience carries the obligation to be honored. I don't have the answer to that question. Nobody does. But I believe that you, everyone who has sat through 10 episodes in 70 minutes and the story of a refrigerator and everything it stands for, you're asking that question in your own way. And the asking of it is already the beginning of the answer. The GE refrigerator in Dad's basement is still running. That low, steady hum, the one I heard all through childhood without understanding what it meant. I understand it now. It's the sound of something built to never surrender. And in this world, at this moment, that is the most revolutionary thing I know. Do we have the courage, those of us who grew up with the hum of steel machines built to outlast everything, who watched them get swapped out for plastic and promises? Do we have the courage to hand down to our children, not the refrigerators, not the history lessons, but the thing that is worth more than either. The belief that building something truly well is never wasted effort, even when nobody sees it, even when nobody records it, even when that machine someday finally goes quiet.